Hello there. It is truly a quiet pleasure to welcome you to this moment of stillness. Wherever you may be, I hope the world outside your door is settling down, folding itself into the soft quiet of the evening. Let your mind become a calm, unhurried space, like a library late at night, where only the most gentle stories are told. Tonight, we are turning our attention towards something that lives everywhere, but is seldom seen for what it truly is: light. We use it to see the world, but have you ever wondered how the light itself sees us? What memories does it carry from its long journey from a distant star, or even just across the room? It moves so fast, yet it tells the slow, true story of everything it touches. The texture of an object, the shade of a color, the history of a moment. We'll trace those old, quiet whispers carried on the light, letting its gentle language reveal a deeper layer of the world we thought we knew. It's a tender, intimate conversation between matter and energy, and we are simply listening in. If these quiet explorations bring you ease, or if you feel a soft spark of curiosity about the science we share here, a gentle like and a soft subscribe truly help others find this calm too. It's how more sleepy souls can find their way home to these stories. For now, there's no rush. The light is patient, and when you are ready, we will begin our wandering together. Softly. Light is a strange companion because it never quite behaves the way we do. When you sit in a car or on a train, even when you're moving quickly, you can still look out the window and feel like a calm observer. Trees slide past, buildings drift by, clouds move along the horizon. Everything is in motion, but you can still tell where you've been and where you're going. There is a clear before and after, a path laid out inside time, and you remain gently aware of it. For light, that familiar sense of order quietly breaks. There is one rule built into the universe that every ray of light obeys, every time, everywhere. It is simple to say, and very difficult to truly feel. No matter how fast you move, you can never catch up to light, with almost anything else that isn't true. If you drive behind a slower car, you can press the pedal and eventually pull alongside it. If you're on a bike and someone is jogging ahead of you, you can pedal harder and close the distance. Speed feels like something you can change and compare, a dial you can turn. But a beam of light will never let you gain on it, no matter what you do. You can stand still, or you can be in a spacecraft racing through space faster than any plane has ever flown. You can imagine throwing every engine and rocket and burst of energy you have into the chase. Still, the light moves away from you at exactly the same pace. It doesn't slow down to meet you halfway or respond to your effort. It doesn't care how fast you were going already. It just runs the universe at its own steady speed, as if it is following a private rule that nothing can persuade it to break. This isn't just a curious detail or a bit of trivia tucked away in a textbook. It is one of the quiet reasons that time and space themselves bend into shapes that feel unfamiliar at first. Light isn't just very fast, it is as fast as anything is allowed to be. There is a hard limit written into reality, and light lives right on that limit. Because it moves at this ultimate speed, it sits in a strange place where our usual sense of time stops working the way we expect and starts to stretch in ways that feel almost dreamlike. If, by some impossible magic, you could ride along with a photon, one tiny particle of light, and truly match its motion, time would stop having meaning for you. You wouldn't feel minutes or hours slipping by, and there would be no sense of waiting for anything. You wouldn't be moving quickly through time or slowly through time. You wouldn't be moving through it at all. There would be no earlier and no later, just a kind of unbroken now, a single moment that never quite turns into the next. Distance becomes strange in this picture as well. For you and me, crossing a room means starting at one point and arriving at another. There is a gap, and it takes time to cross. Even if you walk quickly, you can feel the steps, the gentle shift of your weight, the small sequence of moments that separates there from here. That journey has a beginning and an end, and you notice yourself moving through the space between them. For light, that gap shrinks in a way that is hard to imagine. If you were a photon born in the heart of a star, headed for the eye of someone standing under the night sky, you wouldn't feel a long journey. You would not feel yourself drifting through cold space for thousands of years, slipping past dust and planets and empty stretches of darkness. Leaving and arriving would be part of the same single moment, fused together. From our side, that photon might have traveled since before any familiar culture existed. From the photon side, if it could have one, there would be no waiting at all, only existence and then disappearance in one seamless act. This is hard for us because we live entirely inside time and are gently held by it in everything we do. We measure it with clocks and calendars, with meals and seasons and birthdays. We feel it in the fading of daylight, in the slow change of our own faces, in the distance between one memory and the next. Time is the way our lives hold together. Without it, our stories would fall apart into loose, scattered moments that no longer feel like a life. And yet, from light's point of view, if we gently imagine it having one, this whole framework simply dissolves. Light does not age. It does not pause. It does not endure in the way we do. It just exists, and then it is gone, as if time can't quite wrap its hands around it. So when we whisper to ourselves, "What does light see?" we aren't really asking about eyes or awareness. We are reaching across a deep divide from our world, tied to mass and waiting and the tick of seconds, towards something that moves so quickly that time and distance barely touch it at all. At the same time, light is the reason we can see anything, the gentle courier that brings the universe to our eyes. It carries every sunset you've ever watched, stretching soft colors along the edge of the sky. It carries the glow of a candle in a dark room, the shine on wet pavement after rain, the quiet blue of a screen in your hands. It threads its way between stars and planets, and then between planets and eyes and mirrors and lenses. Without it, the universe would still be there, but hidden, like a book kept forever closed in the dark. Light may not experience time the way we do, but it allows us to watch time unfolding everywhere else. When you look at a star thousands of light years away, the light reaching you left long, long ago. Those photons have been traveling through space for ages, untouched by the years that passed on Earth. They don't know they have been on the move for longer than our cities have existed. They don't know anything at all, of course. But if we let ourselves imagine, just for a moment, we can ask what it would be like to exist with no later, no earlier, only an endless present. Maybe that is why the question stays with us once we hear it. We turn on lamps, we glance at screens, we look up at the sky. We use light constantly, and yet it behaves unlike anything else we know. We live in a world where everything has to push through time, feeling each second, one after another. Light glides along the edge of a world where time can't quite get a grip, slipping free of many of the rules that keep us grounded. To follow light in your mind is to step gently out of your usual habits for a little while. You loosen your hold on neat sequences where one moment follows another in a straight line. You imagine, just a little, a way of existing that doesn't fit inside those tidy boxes. Instead of thinking in terms of waiting and duration, you picture something that simply moves, unbothered, at the same pace, no matter what else is going on. It can help to picture something quieter and simpler to hold this idea. Imagine you are standing beside a very still lake at night. The water is calm, dark, and smooth, holding the reflection of the stars. The air is cool. The world is hushed. For a moment, it feels as though the stillness might last forever, as if nothing will ever disturb the resting sky on the surface of the water. Then a small stone touches the surface. You hear a soft sound, and from that single point, a ripple begins to spread outward. The reflection of the stars shivers. Circles of disturbance widen gently across the lake. The stillness is not destroyed, it is rearranged. That one small act echoes across the surface, carrying the memory of the stone's touch to distant parts of the water, long after the stone itself has vanished beneath. That ripple does not stay where it started. It travels, quietly and steadily. Now, let that image grow larger in your mind. Instead of water, imagine the fabric of space itself. Instead of a stone, think of a small burst of energy, an event, a spark. From that event, a disturbance spreads outward at the speed of light, carrying information about what happened. This is how the universe sends messages from one place to another. Every flash, every flare, every quiet glow is a ripple on that vast, invisible surface. Wherever you are standing on Earth, floating above Mars, drifting in a ship between stars, that ripple moves at the same speed. It doesn't adjust to your motion or take notice of your effort. It doesn't slow down if you chase it, or speed up if you run away. Light always covers the same distance in the same amount of time in empty space, like a heartbeat that never changes its rhythm. Cars don't behave like that. Their speeds add and change. Sound doesn't behave like that. Its speed shifts slightly with temperature and air. Your heartbeat and your breath move faster or slower depending on what you are doing. Almost everything else we know responds to circumstances and surroundings. Light doesn't. It is curiously stubborn, strangely faithful to one pace. In empty space, it travels at about 300,000 kilometers every second, around 186,000 miles. In the time it takes you to take a calm breath, light could sweep around our planet several times. The numbers are so large that they blur in the mind, but the important part is that they do not waver. This speed is always the same. It is one of the fixed threads holding our universe together, a quiet constant that never seems to slip. Because light's speed is constant, it becomes more than a property of light. It becomes the maximum speed at which anything, any piece of information, any signal, any influence can move. News of a star's collapse, the glow of a far-off galaxy, even the gentle warmth of sunlight on your face all travel to you no faster than this. When we look outward, we are always seeing the past, delivered at light's steady pace, never rushed, never late. This limit tells us something quiet and deep about reality itself. If nothing can move faster than light, then nothing can outrun cause and effect. No event can reach across the universe instantly. Everything has to wait for light's messenger to arrive. Time becomes entangled with this speed. It isn't a separate, rigid background anymore, ticking the same way for everyone. It is shaped by motion and energy, and the paths things trace through space, like a fabric, gently stretched and folded by everything that moves within it. Light's constant speed acts like a gentle anchor for everything we've been talking about. It marks a soft boundary. This fast, and no faster. On that boundary, light glides along, carrying every small, shining story from the hearts of distant galaxies all the way to your quiet eyes, resting in the dark, taking in the universe one photon at a time. And it's right at that boundary that light's strangeness deepens, because the more closely you look, the more it seems almost untouched by what we call time. From where we stand, a ray of light can cross the universe while stars are born and die, galaxies collide, and entire civilizations rise and fade. Yet for the light itself, there is no sense of waiting for any of this to happen. The universe ages around it, but for the photon racing through space, there is only an unbroken now, never quite in the past, never quite in the future, just endlessly on its way. To understand how it manages this, it helps to look at what light actually is. It isn't like a car speeding down a road or a ball arcing through the air. Those things need to be pushed, slowed, turned, nudged. They speed up and slow down depending on what happens to them. Light is different. It behaves more like a wave, a pulse, a tiny disturbance that ripples through space itself, carrying energy from one place to another. When you see it that way, the way it keeps its speed begins to feel less like magic and more like a built-in rule of existence. Light moves at the speed it does not because it works hard to get there, but because that speed is woven into what it is. This speed is not just a habit that light falls into when it happens to be traveling. It is a number that sits deep inside the laws of reality, as fixed and dependable as the way gravity pulls or the way mass resists motion. You can measure the temperature of water or the weight of a stone. And you can also talk about the speed of light as something that belongs to the universe itself. It acts like a quiet standard, a measure that other processes must respect. If light's top speed could drift or wobble, even a little, everything else would shift with it. The patterns we take for granted, how atoms behave, how time passes, how cause leads to effect would begin to unravel. And yet, instead of feeling threatening, there is something oddly comforting about this constancy. In a world where so much is changing, weather, moods, seasons, even our own thoughts, light's speed is one of the few things that does not, no matter where you are or how your life is turning, a photon will always cross empty space at the same pace. When it finally reaches you, it brings with it a record of where it has been, the glow of a distant star, the echo of an ancient explosion, the soft shine of a nearby screen. Wrapped up in that quiet constancy is a reminder that, beneath all the shifting surfaces, there are still a few steady threads holding the universe together. If you think of it while you're drifting towards sleep, you might picture this constant as a gentle heartbeat of reality. Light, moving without hurrying and without ever truly slowing down, pulses through the darkness. It never asks how far it has come. It never wonders how far it has left to go. And yet, every time you look up at the stars or glance at your phone, the light reaching you has already traveled farther than your mind can comfortably imagine, still arriving at exactly that same unchanging speed. You can imagine yourself standing on the edge of a boundless horizon, with the skies stretching away in all directions, colors shifting softly across it. For us, that view is a scene unfolding in time. The colors change, clouds drift, the night deepens. We feel ourselves moving along with it, moment by moment. For light, in the way we've been imagining it, everything in front of it is already there. Every point along its path is part of a single continuous now. There is no need to wait to arrive somewhere because, in its own experience, There is no gap between departure and arrival at all. This world, as seen through light, is a world without waiting. For us, the passage of time is almost everything. We count seconds and minutes and hours. We plan our days, remember our years, and feel time pressing gently or urgently on our shoulders. We think of time as something we must move through, a steady current carrying us forward, whether we are ready or not. It shapes how we live, how we hope, how we remember. We are so used to this flow that it is difficult to imagine any other way of existing. But light does not move through time the way we do. When it travels from one point to another, no matter how far apart those points are, it does not experience a delay. For us, the space between two stars might mean millions of years of travel, if we could travel at all. For light, that distance does not stretch out into a corridor of waiting. There is no sense of before or after the journey, no feeling of being in between. In our language, we say that light travels, but from the photon's point of view, all the places it connects are simply present. It doesn't need to cross time to get from one to the other. It exists in a state where those 2 points are folded into the same instant. This strange, eternal now makes light feel uniquely apart from everything else we know. For us, and for every object we touch, time is a fundamental part of being real. We experience it in our bodies, in our memories, in the way things wear down and change. We exist inside time, and time, in turn, gives shape to our existence. Light doesn't seem to share that kind of relationship. It doesn't age, doesn't get tired, doesn't grow older with its travels. It has no need for pauses or second chances or the slow unfolding of events. It simply is, always in motion, always at the same pace. This can be difficult to truly feel, because our lives are built around waiting. We wait for water to boil, for a message to arrive, for morning to come, for the next chapter of our story to reveal itself. The ticking of a clock is more than just a sound. It is a background rhythm that our plans, hopes, and worries all quietly follow. We often measure ourselves by what we are waiting for, by the milestones we are moving toward. In this world of lines and schedules, light stands apart as something that never waits and never has to. From the moment a photon is born, perhaps in the turbulent heart of a star or in the warm filament of a lamp, it moves without interruption. No coffee breaks, no hesitations, no almost there. If you try to imagine the world from its perspective, you find yourself in a reality where the arrow of time is missing. The path from one place to another does not stretch out as steps on a road. Instead, everything collapses into one continuous event, a single act of existence with no beginning, middle, or end. Einstein's ideas about space and time help us put words to this. He showed that time and space are not separate, but part of one woven fabric. When something moves faster, that fabric behaves differently. Time can slow down for the traveler. Distances can contract along the direction of motion. Push that speed all the way up to light's own. And the numbers in the equations tell us that time for that traveler would grind down to nothing, and the lengths in front of it would shrink towards zero. For the photon, there is no waiting for anything, and no distance that truly stretches out. We, of course, can't live in that world. We are made of matter, and matter cannot reach the speed of light. We remain bound to slower paths, where time always marches forward, and distance always has to be crossed. We watch clocks, we mark anniversaries, we feel ourselves growing and changing. We may dream about racing alongside light, but we are always, gently, held back by the rules that shape us. Light slips through those rules in a way we can only imagine. Still, imagining has its own quiet power. As you lie there, you can let yourself ease into the thought of a reality where there is no rush and no delay, because there is no later at all. Light does not hurry to the next moment or cling to the one just past. It simply moves at its own constant pace, untouched by the kind of time that weighs on us. In that sense, it belongs to a layer of the universe that we can never fully step into, but can sometimes glimpse in the way starlight falls through a window, or the way morning light slowly brightens a room. Light exists in a world where every moment, from its own viewpoint, is the same moment. That is what we mean when we say it is timeless. While we wait for the next hour or the next day, light is already spanning the space between here and somewhere unimaginably far away, never thinking of before or after, simply following the quiet rule that keeps its speed unchanged. It hints that there is more to time than the version we live inside, that beyond our clocks and calendars, there is a deeper structure where, for some things, the very idea of waiting does not apply. If, in some dream of the mind, you could match the speed of light, your familiar world of distances and delays would begin to melt. The spaces that separate one star from another, spaces that once felt impossibly wide, would draw closer until they seemed almost folded on top of each other. The road of time that you are used to walking, step by step, would vanish beneath your feet. You would not feel yourself traveling. You would not feel time carrying you. Everything would arrive together in a single, seamless moment. We will never truly live that experience, but imagining it softens something in us. It reminds us that our way of moving through time is not the only way reality can be. While we keep our appointments and count our days, light continues in its ageless, effortless motion, a silent traveler that knows only the present and carries the universe's stories across the dark. And in a way, this imagination connects naturally to something we can observe. The faster you move, the stranger space begins to feel. When you walk across a room, the distance is simple. A few steps, a few seconds, a clear gap between where you start and where you end up. But in the deep language of relativity, as your speed climbs closer and closer to the speed of light, that gap does not stay the same. It begins almost shyly at first, to shorten in the direction you are traveling, as though the universe quietly leans in to meet you. Now imagine that, instead of walking, you are no longer you at all, but a photon racing across the cosmos. From the instant you are born, maybe in the heart of a star or in the glow of a distant galaxy, you are already moving as fast as anything can possibly move. From our perspective, you have an enormous journey ahead, light years of space, oceans of darkness, unthinkable distances. But from your own perspective, if a photon could have one, something astonishing happens. That expanse between where you begin and where you are going does not stretch out in front of you like a long road. It doesn't feel like a journey at all. Instead, the distance simply collapses. For the photon, the space between departure and arrival shrinks toward nothing. There is no in-between, no middle of the trip, no stretch of time hanging between start and finish. In the language of relativity, as you move faster, the distances in your direction of motion contract. Push that speed all the way up to light's own, and the contraction becomes complete. For light, leaving and arriving are part of the same single event, one unbroken moment. This is where the difference between our view from Earth and light's imagined view becomes sharp. From here, we see light crossing vast gulfs. Stars hang far away, their glows separated from us by years upon years of travel. Galaxies appear as tiny smudges in the sky, their light having threaded its way through space since long before we were born. We feel, in a quiet way, the enormity of those distances. But for the light itself, those same distances are not stretches to be conquered. They simply aren't there in the same way. There is no giant hallway of space for it to move through. There is only a single continuous now. For us, space feels huge and open, full of emptiness that must be crossed. For light, in a sense, space behaves more like an illusion, a thing that bends and contracts until all the points it connects are folded into the same moment. That is one of the deep, gentle paradoxes of relativity. The more intensely you move, the more space and time twist themselves around your path. To feel this more personally, imagine that instead of a photon, you are in a spaceship, sleek and quiet, gliding through the dark at a speed very close to that of light. From Earth, your destination might be years or even centuries away. If someone stayed behind, watching you on their instruments, they would say your journey is long. They would count the months, then the years, and see your ship inching its way across those starry distances. But on board, the story feels different. At these extreme speeds, the universe rearranges itself around you. Distances in the direction you are traveling start to compress. The stars that were once far apart now seem to draw closer together, squeezed into a narrower slice of space. Light years of distance, from your point of view, can slip past in what feels like days or weeks. It's as if you are sliding through a thin crack between two enormous walls, while those walls seem to press in from either side. At the same time, time itself changes its rhythm for you. According to Einstein's relativity, the faster you move, the more slowly time flows for you, compared to someone who is moving less quickly. This is not just a trick of perspective. It shows up in clocks and in the aging of bodies. If your ship travels close enough to light speed and then returns home, you would find that less time has passed for you than for those who stayed behind. They would have lived through more days, more years, while you experienced a shorter span. You would have taken a long journey in their eyes, but in your own experience, it might feel surprisingly brief. From your seat by the window of that imaginary ship, you would not feel anything strange in the flow of your own time. Your heart would beat at its usual pace. Your thoughts would unfold one after another in a familiar way. You would eat meals, sleep, wake up, and watch the stars drift past the hull. It would all feel like a normal sequence of moments. But from Earth's perspective, your clock would be ticking more slowly. Your life would be stretching out, time dilating around you like a soft bubble. This is the double effect of relativity. As your speed climbs, the distances ahead of you contract, and your own time slows relative to others. Space shrinks, time stretches, and both of these shifts conspire to keep one rule unbroken. The speed of light remains the same for everyone. No matter how you choose to move, the universe quietly adjusts space and time so that light's pace never wavers. Now, bring your thoughts back to light itself. For us, there is still some journey left, still some stretch between stars and eyes. For a photon, the compression is total. There is no gap between where it leaves and where it arrives. The light that left a distant star billions of years ago and meets your eyes tonight does not experience those billions of years as a long passage. It doesn't experience them at all. From its point of view, there is just the act of leaving and the act of arriving, fused into a single, timeless event. When you lift your gaze to the night sky, You are seeing a collection of such events, each one a quiet memory of something that happened long ago. The stars, as you see them, are not as they are now, but as they were when that light began its journey. Some may have changed. Some may even have faded or transformed entirely. What reaches you is not the present state of those suns, but a record, carried on photons that have been traveling across the dark for ages. The distance between you and them, in the human sense of miles or kilometers, is less important in that moment than the fact that you are receiving their light at all. You are looking at history written in brightness. In that sense, light is more than just a way of seeing. It is a bridge between times and places. It quietly erases the space between here and there, joining them in the single instant when the photon meets your eye. All the long years of travel vanish from its own experience, leaving only the connection, a star far away, and you, right here, sharing one moment. The universe uses light to link its distant parts, sewing together events that are separated by both time and distance, and delivering them to you in the present. This is the paradox of light. It travels across vast distances, yet never feels them. It moves through epochs of cosmic history, yet never waits. For us, there is space and time, and we move through both. For light, there is only now. That now can stretch across the lifetime of galaxies, but from light's side of the story, nothing ever takes any time at all. It is eternally in motion and eternally in the present. Imagine again that you could somehow join it, not just by going very fast, but by doing the impossible and matching the speed of light exactly. In that dream, you would become like a photon yourself, a tiny packet of energy sprinting through space. As you race, something remarkable unfolds. Time stops flowing for you. There is no sense of moments passing, no feeling of later edging closer. There is just one continuous instant, without a past receding behind you or a future waiting ahead. Here on Earth, we live wrapped in clocks and calendars. We mark birthdays, deadlines, anniversaries. We say too early and too late, and feel each day slipping quietly into the past. Time is our constant companion and sometimes our quiet worry. It shapes our choices and memories. But from the imagined perspective of a photon, none of this applies. Time does not move. It does not pile up. It simply does not play a role in its existence. The photon doesn't know how long it has been traveling. It doesn't know that its journey has crossed centuries or more. It does not age. It does not accumulate experiences. It simply is. Einstein's theory gives this dream a mathematical backbone. It tells us that the faster you go, the slower time flows for you relative to someone else. It tells us that at light speed, that flow would come to a standstill. Of course, we, with our mass and our bones and our beating hearts, can never quite get there. The universe keeps that door closed to us. But thinking about what lies just beyond it lets us see our own world more clearly. We realize that time is not a rigid, universal tick, but a flexible thing, shaped by how we move. From our vantage point, someone traveling near the speed of light ages slowly. Their clock lags behind. Their life stretches out. From the traveler's own view, everything feels normal. From light's imagined view, time is not even part of the story. It is a concept that simply doesn't apply. That difference in experience does not mean that one version is wrong and the other is right. It means that reality is richer and more layered than our everyday intuition suggests. As you rest here, you don't need to solve the equations or hold every detail in your mind. It's enough to let the feelings settle in that there are ways of existing in this universe that do not depend on the steady march of seconds the way we do. Light moves through a world where distance can collapse and time can fade away. We move through a world where steps and hours shape everything we know. Between those two, there is a kind of quiet conversation. When you watch a beam of sunlight fall through a window or catch the cold, steady glitter of starlight, you are touching that quiet conversation between the universe and your senses. The photons arriving now began their journeys long ago, yet they deliver themselves to you in a single, simple moment. To them, there was no road, no waiting, no duration, only now. To you, there is a life full of before and after, wrapped around that one point of light. In the gentle space between those two perspectives, time becomes something soft and mysterious, and light becomes not just what lets you see the world, but a reminder that the universe can be far stranger and far more beautiful than the version we carry in our everyday thoughts. And that mystery deepens when you consider how light itself seems to exist in its own way of being. It does not see the world as we do. It doesn't seem to need time or distance in the way our lives depend on them. When we talk about a photon, we're talking about something that moves through the universe at the ultimate speed, yet never quite settles into the familiar rhythm of before and after. In our imagination, it lives in a realm where everything happens at once, where all the places it touches are folded into a single, continuous present, a presence that stretches through what we call space and time, yet never fully seems to feel either. From this imagined photon's point of view, time stops being a solid, unchanging backdrop. It becomes something flexible, something that can bend and stretch depending on how you move. For slow beings like us, time flows in one direction, steady and familiar. For a traveler moving very fast, it begins to slow. And for light, racing at the ultimate speed, that flow seems to disappear altogether. Time, as we measure it, loses its power. It doesn't drip forward in seconds or years. It simply doesn't apply. The next time you look up at the stars and think about the light that has crossed the universe to reach you, you can remember this quiet strangeness. That glow is not just coming from far away in space. It is coming from a kind of timeless state, from a way of moving where the usual grip of time has slipped loose. The photons entering your eyes have existed in a reality where there is no waiting, where the present stretches out without edges, and where the ideas of earlier and later no longer make sense. For light, there is no past to look back on or future to anticipate. There is only now, and in that now, everything it connects is linked instantly and effortlessly. To feel the difference, imagine embarking on a journey. When you travel, you notice the road beneath you, the change in scenery out the window, the slow unfolding of landscapes. There is a starting point, then a middle, then an arrival. You feel bumps, hear engines, watch the sky shift color. The journey is a collection of moments laid out one after another, each one slightly closer to your destination. You experience distance through time, and time through distance. Now try to imagine a journey where none of that happens. You begin, and in the very same breath, you are already there. There is no sense of motion, no scrolling of scenery, no interval between leaving and arriving. The trip exists as an idea, but it never feels like a trip at all, more like simply being, with no need to cross anything. This is close to what we mean when we say that light travels. For a photon moving at the speed of light, the concept of going from here to there loses its usual meaning. There is no getting closer or farther away, no halfway point. There is only one continuous moment in which the entire path is contained. For us, a journey is a line drawn through both space and time. We step along that line, and each step takes a little while. We are always somewhere between the place we left and the place we're going. We can say, "I'm almost there," or "I've just started." We can measure our progress in hours and kilometers, but light doesn't measure its movement like that. It doesn't know about almost or not yet. From its side of things, there is no space to cross, because all the points of its path are pressed together into a single instant. If you imagine flying straight from Earth to a distant galaxy and somehow compressing the entire trip into one indivisible moment, you come close to light's experience. The beginning and the end would merge. There would be no way to say how long it took, because it wouldn't take any time at all. The journey would be both completed and ongoing in the same breath. To the photon, there is no awareness of leaving one place and heading toward another. It is simply always where it is needed, as soon as it is created. That idea, a journey that isn't really a journey, is deeply at odds with how we live. We are bound to time. We wake up, move through our days, grow older. We measure our lives in small units, seconds, minutes, hours, years. We feel the weight of waiting, waiting for news, for change, for rest, for tomorrow. Every step from one point to another is tied to a little slice of time that we can feel passing. For us, there is always a through, always a moving from one moment to the next. Light simply skips that part. For light, there is no through time, no marching forward from moment to moment. There is just one moment, endlessly present. It exists in a kind of perfect unity with its path, moving without ever feeling that it moves. It is always arriving as soon as it leaves. That is part of what it means to be a photon, to be a traveler for whom the idea of traveling has dissolved, leaving only presence. The consequences of this are gentle but profound. We think of light as a messenger, carrying information from one place to another, a signal from a distant star, a reflection from a nearby wall, a pattern picked up by a telescope. Yet that message always arrives in our now. We receive it as something happening in the present, even when we know that the photons were set loose long ago. Light does not experience the wait between those moments. The story it carries is stretched across time, but it meets us in a single instant. This creates a paradox that can be strangely soothing to think about. When we look at the night sky, we know we are seeing the past. Some of the stars we see may have changed or even vanished since their light began its journey. The photons touching our eyes tonight were born billions of years ago. Yet for us, they are entirely present, part of this particular quiet evening. We see them as if the stars are still there, still shining, still speaking to us. From the light's side, if it could have one, the moment of being emitted and the moment of arriving are tightly entangled. They are not separated by a long road of time. There is no waiting room between them, no pause, no later. There is only one unbroken now, in which both events are held together. That difference between our experience and light's imagined experience shows just how deeply we are wrapped in the passage of time, and how different it would be to live outside of it. And yet, for all this strangeness, light is how we learn about the universe. It brings us the stories of distant galaxies and quiet nebulae, of stars being born and stars burning out. It lets us see things that no one has ever touched. It allows us to look back toward the early moments of the cosmos, reading faint whispers in the glow that still hangs between galaxies. Light is a witness to almost everything, but it is a witness who does not feel the weight of age or delay. It records without waiting. It carries without ever having to say, "Not yet." Part of the reason light can live this way has to do with something simple but important. It has no mass. Everything, with mass, stones, planets, your own body, is tied tightly to the rules of time. Mass gives things weight and solidity, and it also anchors them to the fabric of space-time. When you throw a ball, you feel its heaviness in your hand and the resistance of the air as it moves. It takes time for it to go from you to where it lands. During that time, it is fully inside the flow of time, aging along with you, subject to gravity and friction and all the little forces that slow it down. Light is different. Because a photon has no mass, it isn't bound in the same way. It doesn't feel the drag that objects with mass feel. It doesn't need to be pushed to keep going, and it doesn't slow down as it moves through empty space. Even when it passes near something massive, like a star or a galaxy, and its path bends around that object, its speed remains the same. Space and time curve, but light glides along those curves without ever losing its pace, like a leaf following the shape of a river without changing its own nature. Einstein showed that mass and energy both shape the fabric of space-time. A massive planet or star presses down on that fabric, bending it so that paths curve and time ticks more slowly near its surface. The more mass something has, the more it distorts the space and time around it. Objects with mass have to struggle against those distortions to move faster. The harder they push, the more resistance they feel. As their speed increases, their own time slows down relative to those who stay behind, and it becomes harder and harder to add more speed. In that sense, mass is always a little behind light. It can approach that ultimate speed, but never quite touch it. The universe seems to protect the boundary where light lives, making it unreachable for anything with weight. Light, being massless, is free in a way that nothing else is. It does not tug on space-time the way heavy objects do. It simply travels along the curves that mass creates, obeying the shape of the universe without ever being fully tied to it. As you lie here, letting these thoughts drift in and out like slow waves, you don't have to hold onto every detail. It's enough to let a few simple images settle. Light as a traveler whose journey takes no time at all. Space as something that can collapse into a single moment. Mass as the quiet weight that keeps us rooted in the flow of time. We live inside that flow, counting our days and our distances. Light moves along the edges, timeless and effortless, carrying the universe to us one photon at a time. No matter how much energy you pour into an object with mass, there is always a kind of quiet resistance in the way. The faster you try to push it, the harder the universe seems to push back. Time slows for it, its energy climbs, and yet it never quite reaches the speed of light. Mass and light, in that sense, are like two great opposites in the story of the cosmos. Mass feels the full weight of space-time's rules, while light seems to slip along the edges of those rules in a way that nothing else can. Because light has no mass, it doesn't experience that same resistance. It moves through space-time at one steady pace, not needing to be pushed and never needing to slow down. Gravity can bend its path, curving the route it takes around stars and galaxies, but it does not change that underlying speed. Light threads its way through the warped fabric of the universe with a kind of effortless grace, following the curves without ever losing its rhythm. That is part of what makes it so fundamental to how we understand everything else. Mass, with its weight and pull, shapes space-time. It presses into the fabric, tugging on everything nearby, and changing the way both matter and light move. Planets, stars, and even clusters of galaxies all bend this fabric simply by existing. Light, on the other hand, rides along those bends like a traveler crossing hills and valleys, never stopping, never resting, but always faithful to its speed. While mass and gravity sculpt the landscape, light wanders through it as a constant, revealing its shape. If you've ever watched a thin beam of sunlight pouring through a gap in the curtains, or seen a shaft of light cut across a dim room, it's easy to forget how strange it really is. To our eyes, it feels familiar and ordinary. It brightens dust motes, outlines leaves, paints the floor in pale gold. But behind that everyday softness is something quite radical. Light does not carry mass. It does not wait. It does not age as it moves. It is both very present, touching your skin, entering your eyes, and at the same time unburdened by the anchors that hold everything else in place. It helps to imagine that space itself is not as rigid as it looks. Instead of being a fixed, empty stage on which things move, picture it as something soft and flexible, like a sheet of cloth. Under the influence of mass and energy, this cloth can bend, stretch, and even fold. Einstein's general relativity tells us that space and time together form a fabric that responds to what is inside it. Put something massive on that fabric, and it dips. Move something heavy across it, and tiny ripples spread outward. The trampoline image is a simple way to feel this. Imagine that space-time is the stretchy surface of a trampoline, and you are standing at its center. Lay a heavy ball on it, and the fabric sinks around the ball. A smaller marble rolling nearby will not travel in a straight line anymore. It will curve inward, pulled by the dip. In the universe, mass does something similar. A star or a planet presses down on space-time, and everything near it rocks. Gas, even beams of light, follows curved paths, because the floor beneath them is no longer flat. If you let your mind wander to more extreme places, you arrive at black holes, where that bending becomes so intense that space-time is pulled almost to a breaking point. A black hole is like a place where the trampoline's fabric has been stretched thin and pinched into a deep well. The closer you get, the steeper the slope becomes, until, near the event horizon, even light cannot escape. From far away, it looks like a region where not even a single photon can climb back out once it has fallen in. At the horizon itself, our usual sense of distance and time begins to blur. From outside, it seems as though anything falling toward that boundary slows down, its time stretched out until it almost freezes. From the falling object's own point of view, time feels more normal, but space around it twists in strange ways. Directions get confusing, distances can feel distorted, and in some descriptions, the universe seems to flatten and compress, as if space is running out of room to stay spread out. The familiar idea of here and there begins to lose its meaning. This thinning and warping of space at a black hole is an extreme version of something that, in gentler form, happens everywhere. Whenever something massive moves, whenever energy shifts, space-time responds. It stretches and ripples, carries faint waves outward, and subtly changes the paths that other things will take. As speeds increase and gravitational fields grow stronger, distances in the direction of motion can begin to compress, and time can slow down. Space, which we like to imagine as empty and still, turns out to be active and responsive. If you could travel near the speed of light, you would discover this in a very personal way. The stars ahead of you would seem to draw closer together. Distances that once felt impossibly large would shrink in the direction you are going. The universe would no longer feel like a vast, open room, but more like a long corridor whose walls have begun to slide inward. Space itself would seem thinner, pressed, and reshaped by your motion. At the same time, your own time would tick more slowly compared to those far away, another quiet expression of how deeply space and time are woven together. All of this reminds us that space is not just a passive backdrop. It is a dynamic fabric that is constantly being pulled, stretched, and folded by everything in it. From tiny particles to massive galaxies, every bit of mass and energy leaves a trace in the way space-time curves. Light, racing along at its constant speed, travels through this ever-changing landscape and gives us a way to see it. Each ray tells us something about the path it has taken, how much space was warped, how much time was slowed, how deep the valleys, and how gentle the hills of the cosmic fabric really are. When you step outside at night and look up, you're not just seeing isolated points of brightness. You are looking into a web of relations, space bending around stars, galaxies clustered in great threads, and light weaving through it all. That light is both a messenger and a boundary for us. It connects us to places far beyond our reach, yet it also sets the limit of what we can know. Beyond where light can reach us, there may be more universe, more space, more stories, but without light, they remain hidden, wrapped in darkness. In that sense, light quietly defines the edges of our reality. It shows us how far we can see and how far back in time we can look. It paints the world around us with color and shape, and it carries, in its gentle, unwavering speed, the imprint of the cosmic fabric it has crossed. Without it, we would be surrounded by a universe we could never truly sense. With it, we are given a glimpse of how strange, flexible, and beautiful that universe really is. As light travels through space, it quietly draws the outline of everything we can know. Each photon that reaches us is like a small pulse saying, "Here I am. This is where I came from. This is how it looked when I left." At the same time, every place that light has not yet reached or cannot escape from falls into shadow for us. The reach of light becomes the edge of our vision, the soft boundary of our understanding. When you look up at the night sky, you are not seeing the stars as they are right now. In this exact moment, you are seeing them as they were when their light began its journey toward you. For some, that journey has lasted hundreds, thousands, or millions of years. A star you admire tonight might have already changed, or even faded away, but the light it released long ago is only just arriving now, carrying with it a message from a vanished moment. In that way, light doesn't only illuminate the present, it carries echoes of the past, delivering them gently into our now. The very speed of light draws a line between then and now. Anything whose light has not had enough time to reach us remains invisible. Beyond that horizon, the universe may continue, but for us it is hidden, waiting for photons that may never arrive. Light does not just let us see, it defines what can be seen at all. Wherever it is blocked, absorbed, or forever trapped, our picture of reality stops. It is as if light hangs a curtain between what is revealed and what remains unknowable, and we live on the bright side of that curtain. This is as true for time as it is for space. Because light moves at a constant speed through the fabric of space-time, It carries information not only about where something is, but when it was. The delay in its arrival becomes a measure of distance and of history at once. The speed of light sets the pace at which cause and effect can communicate, the rate at which events can influence each other. It forms the backbone of our understanding of time's flow, the spacing between one moment and the next. But this clarity begins to blur in the most extreme places in the universe. If light is the thread that connects us to distant events, what happens where that thread is cut? What happens at the edges of black holes, where gravity grows so deep that even light cannot climb out? In those regions, the fabric of space-time is bent so sharply that it seems to fold back on itself. Light that strays too close becomes trapped, circling inward, unable to send any message back out into the wider universe. The boundary of a black hole, the event horizon, is a kind of ultimate edge. Anything that crosses it disappears from our view, not because it no longer exists, but because its light can never reach us. Information that would usually ride out on photons is locked away. From the outside, we can only see the effects at the horizon itself. The way light is stretched and reddened, the way time appears to slow for anything falling in. Beyond that thin, invisible surface lies a region we can describe with equations, but never directly observe. Deep inside, our current theories suggest that space-time might collapse into a singularity, a place where density soars and the rules we know no longer make sense. There, our familiar ideas about distance, time, and even cause and effect begin to fray. The boundary between the known and the unknown is no longer a gentle line, but a chasm. And yet, strangely, the fact that light cannot escape is itself a clue. It tells us that gravity can reach a strength where even the universe's fastest messenger fails. It tells us that space-time can bend so much that paths which used to lead outward fold back inward instead. So, we live outside these horizons, in a universe where light still reaches us, defining the farthest galaxies we can see and the earliest moments we can study. The boundaries of light are not just physical distances, they are also the edges of our knowledge. Everything we understand about distant stars, swirling nebulae, and the glow of the early cosmos comes from light that has managed to travel to us. Beyond that, there are regions we can only imagine, because no photon has ever arrived from there to tell us their story. Even so, light remains our key. It may set edges, but it also stretches those edges outward, giving us more and more of the universe to hold in our gaze. Without it, we would be left in pure darkness, unable to sense the size or shape of the cosmos around us. With it, we can trace the contours of reality right up to the places where light stops, and there, at those edges, we meet our deepest questions. From these vast scales, you can let your attention gently shrink down, from galaxies and black holes to something much smaller, the behavior of light itself, when we look very, very closely. If the cosmic horizon shows us the outer boundary of what light can tell us, the quantum world shows us the inner boundary of what light actually is. And in that small, delicate realm, the edges between ideas begin to blur again. Imagine looking at the world through a soft fog. Shapes are still there, but their outlines melt into one another. Things that used to feel clearly separate begin to overlap. This is a bit like the way light behaves in the strange world of quantum mechanics. It refuses to stay neatly in one category. For a long time, we thought of it as a wave, a smooth ripple, spreading out, bending around corners, creating gentle patterns of light and dark, when it passes through slits or around objects. This picture explains the colors of a rainbow, the shimmer on a soap bubble, the way light diffracts when it meets an edge. Then, in the early 20th century, experiments began to show another side. When light interacts with matter, when it knocks electrons off metal, or is absorbed one tiny piece at a time, it behaves as if it is made of little discrete packets of energy. These packets, photons, behave like particles. They can arrive one by one, be counted, be absorbed in single jumps by atoms. It was as if the graceful wave had suddenly revealed itself to be a shower of tiny grains at the same time. How, then, do we describe something that is both spread out like a wave and localized like a particle? Quantum mechanics answers not by choosing one side, but by telling us that both are true, in a way that doesn't quite match our everyday intuition. Before we look closely, a photon doesn't sit neatly in one box or the other. Instead, it exists in a quiet haze of possibilities, able to show us wave-like behavior in one kind of experiment and particle-like behavior in another. Only when we perform a measurement, when we ask the universe a very specific question, does light choose a form that fits that question. This delicate state, where light is not fully one thing or the other, is sometimes called superposition. It is a kind of in-between, a liminal space where multiple possibilities coexist. The wave pattern is there in potential, the particle impact is there in potential, and the outcome depends on how we decide to look. It is not just that we don't know what light is doing until we check. It's that, in the quantum picture, what it is doing is not fully decided until that moment of interaction. Wave-particle duality is not only a property of light. Electrons, atoms, and even small molecules can show similar behavior when we examine them at their tiniest scales. They can behave as spread-out waves of probability or as localized particles, depending on the context. Reality at this level is less like a row of solid stones and more like a shimmering field of options, slowly resolving into something definite when touched by a measurement. You can think of it as a kind of quantum haze through which light and matter both move. Inside this haze are usual categories, wave and particle. Here and there, this or that lose their sharp edges. Until we ask a precise question, the system holds many answers at once. The moment we ask, one answer becomes real for us, and the others quietly fade into the background of what might have been. So, when you look at a beam of light, you are seeing something that is, in a quiet way, more than a single idea. It is both a vibration spread through space and a collection of tiny quanta. It is both continuous and discrete, both gentle wave and single step. It slips between these descriptions the way light itself slips between stars and planets, never fully owned by either. And this is only the beginning of the strangeness. In the quantum world, not only can a single photon live in that hazy in-between, but pairs of photons can become linked in a way that stretches our understanding even further. There is something almost unsettlingly beautiful about the idea that two things, separated by a great distance, can still remain connected. This is not metaphor. It is something we can measure. It sits at the heart of quantum mechanics and is known as entanglement. You can imagine two photons born together in a single event, perhaps in a quiet corner of a lab here on Earth, or in some distant, energetic process in the universe. From that moment on, their properties are intertwined in a way that ignores the usual separation between here and there. But that is a story we will let drift at the edge of your thoughts for now. like two tiny points of light, quietly linked across the dark. From the moment two photons are born together, something quiet and invisible links them. You can think of it as a thread so fine you could never see it, yet so persistent that no distance can cut it. You could keep one photon near you and send the other to the far side of the Earth, or even imagine it drifting between distant stars, and still this connection would remain. When you measure one of them in a certain way, you suddenly know something about the other, no matter how far apart they are. This is not a trick of language or a gap in our understanding. It is one of the most carefully tested features of the quantum world. The idea unsettled even Einstein, who described it as spooky action at a distance, as if reality itself were reaching across space in a way that felt almost impolite. But over and over, experiments have confirmed that this strange link is real. In quantum mechanics, we call it entanglement. When two particles become entangled, they stop being fully separate. Their properties, like tiny compass needles or spinning tops, become part of a shared state. If you later find one spinning one way, the other must complete the picture, no matter how far it has wandered. The moment you learn something about one, you learn something about the other. It isn't that a signal races between them faster than light. It's that, in a deep sense, there was never really a gap for a signal to cross. They are not two independent objects exchanging messages. They are one system, stretched out across space. Once you see it that way, the usual ideas of here and there begin to soften. If entangled particles are different faces of the same underlying state, then distance, at least for that connection, doesn't matter as much as we thought. Space is still there, with its stars and planets and long, empty stretches, but the entangled pair lives in a layer of reality where those stretches don't define the relationship. The link doesn't unfold in time. It doesn't wait. It simply is. Some physicists wonder what happens if we scale this idea up in our imagination. What if entanglement is not rare or special, but woven everywhere into the fabric of the universe? If that is so, then reality is not just a collection of separate things drifting in a big, empty container. It is more like a web of relationships, a network of invisible threads connecting particles, fields, and perhaps even whole regions of space in ways we are only beginning to guess at. Light, in that picture, might not just be a lonely traveler, but part of a larger pattern of connection. The photons that reach your eyes tonight, after crossing vast distances of space, might themselves be quietly entangled with others somewhere else. Their existence may be tied to events you will never see, to particles you will never meet. Entanglement does not behave like a story told from one moment to the next. There is no, first this happens, then that responds in the ordinary sense. It suggests a kind of simultaneity that sits outside our familiar flow of time, a reminder that our neat chains of cause and effect are not the only way reality can arrange itself. In the lab, we separate entangled particles by centimeters, by meters, by kilometers, and still the correlations hold. The measurements here echo the measurements there, as though the space between them has been folded up and tucked away. To us, it feels like the world is quietly whispering that distance is not quite as absolute as it seems. Some scientists now suspect that these invisible connections might be more than curious decorations on top of physics, that they might be the deep structure of physics itself. In some ideas, space-time, the very stage on which everything plays out, might emerge from a vast underlying mesh of entanglement. If that is true, then light itself might be one of the ways that mesh becomes visible. Each photon would not just be a particle of energy, but also a small glimpse of how the universe ties itself together underneath. Entanglement would then be less a quirk and more a hint that nothing is ever truly alone, that every speck of existence belongs to a larger, unbroken whole. We live in a universe of hidden threads, and those threads do not stop at the edges of space or the flow of time. While entanglement whispers of deep connections, the horizons of the universe remind us of deep limits. Everywhere else, light travels freely, racing across the darkness, weaving together stars and planets and eyes. But there are places where even light must stop, places where the map of reality seems to end, not because there is nothing beyond, but because light can no longer return to tell us what is there. The most dramatic of these places is the event horizon of a black hole. You can imagine it as a silent cliff, made out of geometry rather than stone. A boundary without a visible wall. On one side, light can still escape. Photons leaving the region outside the horizon can curve and struggle, but eventually find their way out into the wider universe. On the other side, just beyond that invisible line, every path inward becomes too steep. No matter how fast light moves, and nothing moves faster, it cannot climb back up. From far away, this boundary does not glow or shimmer. It is defined, not by what it shows, but by what it hides. As matter or light falls toward it, we see their signals slow and soften, stretched by gravity. Photons from their surface become redder, fainter, until they fade from view entirely. To us, it can look as though they never quite arrive, hovering near the horizon, frozen in slow motion. But in their own experience, there is no pause, no endless delay. They cross the horizon in a finite time and continue inward, toward regions that our senses and instruments can no longer reach. It is as if two stories are being told at once, one for the distant observer, where the event horizon acts like a final, unreachable shell, and one for whatever falls in, where the same boundary is passed in an instant. Light is at the heart of both stories, revealing how gravity can stretch and twist time itself until different observers disagree about what later even means. On far larger scales, the universe has another horizon, the cosmic horizon, the farthest distance from which light has had time to reach us since the universe began expanding. Beyond that, there is more cosmos, more stars, more galaxies, but their light has not yet, and in some cases will never, arrive. Space between us and them is stretching so quickly that their photons can't close the gap. They are not hidden because they are dark, but because they are forever out of reach. Their existence is part of the universe, but their light will never be part of our sky. These horizons, the event horizon around black holes and the cosmic horizon around our observable universe, teach us something humbling about light. Even this fastest messenger is not limitless. It can be trapped by gravity, or outrun by the expansion of space itself. There are regions from which no photon ever returns, and regions whose photons will never arrive. Light, which defines so much of what we know, also outlines the regions we can never know directly. Yet these boundaries are also guides. The event horizon shows us where gravity becomes strong enough to fold space-time almost back on itself. The cosmic horizon shows us how the universe has expanded over time, shaping the size of the observable cosmos. By studying how light behaves near these edges, how it bends, how it fades, how it disappears, we learn where those edges lie and what they mean. Even when photons are lost beyond a horizon, the ones that come close and just escape carry whispers of what lies near that boundary. If you could somehow hover safely near the event horizon of a black hole and look outward, the universe would appear distorted and warped. Light from stars behind you would curve around the black hole, forming strange arcs and rings. Colors would shift, time would feel different. But when you turned your gaze inward, past that border, there would be only darkness. Not because nothing is there, but because no light can bring you its image. The horizon is at once a physical boundary for photons and a conceptual boundary for our knowledge. Some ideas in modern physics go even further and suggest that horizons might be more than just edges. In certain theories, the information about everything that falls into a black hole, or even about the entire universe, could be encoded on a kind of cosmic surface, like patterns on the skin of reality. This is sometimes called the holographic principle, the suggestion that what happens in a volume of space might be fully described by data on its boundary. If that is so, then horizons are not just places where light stops. They are places where the universe writes down its deepest secrets. Light shows us those surfaces. It tells us where horizons are and how they shape the space around them. But it cannot go beyond them and report back. It is both our guide and our limit, drawing detailed maps of everything within its reach, and then, at the edges, falling silent. When we follow light as far as it can go from entangled photons in the lab to the horizons of black holes and the edge of the observable universe, we find a reality filled with threads and boundaries, unity and limits, all at once. Somewhere in that quiet interplay, between what light reveals and what it can never show, between the connections that ignore distance and the horizons that forbid passage, is the world we live in. A world where you, resting in the dark, can close your eyes and still feel, in some small way, the vastness of a universe stitched together by light, shaped by gravity, and softened by quantum haze, all unfolding just beyond the edge of your thoughts. Out beyond every horizon, there are places no photon will ever return from. They are not walls in any ordinary sense. There is no stone, no barrier to touch. Instead, they are the places where even light, with all its speed and freedom, reaches a quiet limit. It is as if the universe itself has drawn a line and whispered, "This far and no farther." You can imagine light as a tireless traveler, gliding through space without pause. Nothing can outrun it, nothing can match its pace. It slips past planets, threads between stars, crosses the dark gulfs between galaxies as though distance were nothing more than a suggestion. And yet, scattered through that darkness are regions where even light has no choice but to yield. Places where gravity has become so intense that the very shape of space curves inward, and the paths that light would normally follow are bent into a downward spiral. These regions are black holes. They do not grab light the way a hand catches a ball. They do not chase photons and drag them back. Instead, they reshape the road itself. The stronger the gravity, the steeper the slope in space-time. Light always moves along what, locally, is the straightest possible path. Near a black hole, those straight paths simply lead inward. From our perspective, it looks like the ultimate trap. From light's perspective, if it could have one, it is just following the geometry of the universe, as obedient and effortless as ever. As rays of light pass near a black hole, their journeys begin to look strange from far away. Some will just skim past the edge and be flung outward again, their paths wrapped around the hole in graceful arcs. This is gravitational lensing, the black hole acting like a distorted lens, bending the light from stars behind it into rings and stretched smears. Space itself becomes the glass, and the black hole, the curve that shapes it. But for photons that stray too close, there is a final boundary, the event horizon. At that invisible surface, every path forward leads deeper in. A photon cannot slow down and turn around. It cannot decide to change direction, because the geometry of spacetime no longer offers any path that leaves. It crosses the horizon in an instant, from its own side of the story, and never reappears in ours. To us, it simply vanishes. Even before that crossing, gravity leaves its mark. As photons fall toward a black hole, their energy is stretched by the intense gravitational field, a process we call gravitational redshift. Their wavelengths lengthen, their colors slide toward the red, then into shades no human eye can see. To a distant observer, the light from something falling in grows fainter and redder, slowed and stretched out in time. At the edge, it seems to hang almost motionless, fading into darkness. Yet in reality, the photon doesn't freeze. It continues inward, beyond the horizon, into a region no light can report back from. What happens to it there, we do not yet fully know. Some ideas suggest that information about what fell in is somehow imprinted on the horizon itself, like writing on the surface of a sphere. Others imagine that it is carried all the way to a dense, mysterious core, the singularity where our current understanding loses its footing. In either case, our questions accumulate at the threshold. No signal returns to answer them. If you could hover safely just outside an event horizon, space would look unlike anything you've seen. Light from the universe behind the black hole would be bent into strange loops around it. Stars would appear doubled, ringed, or stretched. Some photons would orbit the hole multiple times before reaching your eyes, letting you glimpse regions of space from impossible angles. You might even see the back of your own head, the light that left you swinging around the black hole and coming back. In this dizzying view, black holes reveal something gentle but profound. Space is not a rigid stage, and light is not the untouchable outsider we sometimes imagine. Both are bound to the same deep structure. The black hole does not force light to obey some new rule. It simply reshapes space-time, and light, keeping its character, follows. Even as black holes hide light, they also help us map the extremes of the universe, turning photons into traces of the most intense gravity we know. Around many black holes, especially the giants at the centers of galaxies, matter spirals inward before crossing the horizon. As it falls, it heats up and glows fiercely. In some cases, these swirling disks and the jets they launch can outshine entire galaxies, turning the surroundings of a black hole into one of the brightest beacons in the sky. The hole itself remains dark, but the way it sculpts and energizes light around it draws a glowing outline of where it sits, a luminous frame around an invisible center. Still, despite all that brightness, the horizon stays absolute. For light, it is a one-way gate. Once crossed, there is no return. For us, it is the end of direct knowledge, the point beyond which we can only infer and imagine. Light, which usually defines our sense of distance and time, reaches its final limit there. And in that quiet failure to escape, it tells us something essential about how far our understanding can go. Yet not all journeys of light end so abruptly. Far from the crushing grip of black holes, there is another story, older and more spacious, written in a gentler glow. If you could somehow switch off every nearby star, dim every galaxy, and remove every beam of light shining in the present universe, you would still not find complete darkness. Instead, you would be surrounded by a faint, uniform glow spread across the entire sky. You cannot see it with your eyes, but delicate instruments can. This is the cosmic microwave background, the oldest light we know. This light was born when the universe itself was very young. In its earliest moments, everything was crowded together in a hot, dense soup of particles and radiation. In that early fire, light could not travel freely. Photons were constantly colliding with charged particles, scattered again and again in every direction. The universe was more like a glowing fog than a clear sky. There was no open path for light to escape. Then, after about 380,000 years, a blink on cosmic timescales, the universe cooled enough for electrons and protons to join into neutral atoms. Suddenly, the fog cleared. Photons no longer hit into charged particles at every step. For the first time, light could move through space largely undisturbed. In that moment, the universe became transparent, and the trapped light was released, streaming outward in every direction. Those photons have been traveling ever since. Over nearly 14 billion years, as the universe expanded, their wavelengths stretched, their energy thinned, and their color shifted from brilliant brightness down into the microwave range, far beyond what human eyes can catch. What was once blazing has become soft and cold, yet it is still there, bathing every part of space. No matter where you point a sensitive antenna on the sky, you find this same ancient glow, almost perfectly uniform, with only tiny ripples in temperature. When we observe this faint background, we are not just looking far away, we are looking back in time. Each photon in the cosmic microwave background is a messenger from the early universe, carrying the imprint of what things were like when the cosmos was young and newly transparent. Imprinted in that glow are very slight variations, small patches that are a little warmer or cooler than average. These tiny differences mark where matter was just a little denser or thinner than elsewhere. Over billions of years, those ripples in density would grow under the pull of gravity. The slightly denser regions attracted more matter, swelling into the seeds of galaxies and clusters. The cosmic web of structure we see today, vast filaments of galaxies, empty voids in between, has its first outlines, traced in those delicate patterns in the microwave background. In that sense, this old light is a kind of memory. It holds a frozen snapshot of the cosmos when it was still very simple, before stars and planets and people, and yet already carrying the blueprint of everything to come. What is striking is how unchanged this light is in its essence. It has been stretched and cooled, but the information it carries has survived almost untouched. It has crossed an expanding universe, drifting past forming galaxies, through eras of star birth and star death, quietly passing by worlds that never knew it was there. It has watched, in its own timeless way, as the universe grew and changed around it, and still it continues, washing through every corner of space. Right now, as you sit in whatever room you are in, that ancient light is passing through you. It moves through the walls, through the air, through your own body, an unseen sea of soft photons that has been present for nearly the entire history of everything. You don't feel it, and you don't see it, but it is there, an echo of the first time the universe let light go free. When we think about light, we often think about what it reflects off, the bright surfaces it reveals, the colors it brings to life, the stars it lets us see. The cosmic microwave background does something slightly different. It doesn't illuminate objects so much as it illuminates time. It lets us peer beyond the familiar universe of galaxies and into a younger, simpler era, when space was filled with a nearly uniform glow. It is less like a flashlight and more like a window, opening directly onto the past. And this journey is not over. As the universe continues to expand, The wavelengths of this ancient light stretch even further, growing longer and colder. There is no destination waiting for it, no wall where it will stop. It simply keeps going, filling whatever space there is, its energy thinning but its story intact. If light could tell its own tale, this would be the longest one, set free when the universe was still an infant, still moving now, unaged in its own experience, carrying the first clear image of the cosmos through an ever-growing night, somewhere between the light that falls into black holes and is lost beyond horizons, and the light that has been traveling since almost the beginning of time, lies the quiet truth that you are listening to. Light, for all its speed and simplicity, holds both the edges and the memories of the universe. It traces the limits of what we can know, and at the same time reveals how much came before us. And as you rest, it continues its journeys into darkness, across expansion, through the deep past, steady, patient, and always on its way. If you want to understand the history of the universe, you don't need to dig into the ground or search for forgotten ruins. You only need to follow the light. Every beam, every quiet photon, every faint flicker crossing the darkness is a record of something that once happened. Light is not just illumination, it is memory. It moves forward without tiring, carrying with it stories that stretch across billions of years, written in a language of distance, color, and time. When you look up at the stars, you are looking into this memory. The light that reaches you tonight has been on its way for years, centuries, sometimes longer than any human civilization has existed. Some of it left its source long before there were cities, long before there were animals, even before there was an earth for that light to eventually shine upon. A star 100 light years away shows you its face from 100 years ago. A galaxy a billion light years away offers you a glimpse of itself as it was a billion years in the past. We do not see the universe as it is. We see it as it was, line by line, frame by frame, as light delivers each piece of the record to us. Unlike us, light does not age or forget along the way. A photon born in the violent heart of a star does not slow down as it travels. It doesn't get tired or blurred by time. It simply goes straight and steady until it meets something that can absorb it, a grain of dust, a planet's atmosphere, the mirror of a telescope, the delicate surface of an eye. In that moment of arrival, it releases its story. Without words, it tells you where it came from, what the temperature was there, what kind of atoms it passed through, whether its home was rushing away from you or drifting closer. This is why astronomers sometimes call light a time machine. They are not being poetic, they are being literal in a gentle way. Every photon we catch is a messenger from another moment. The faintest galaxies at the edge of our instruments are not just distant, they are ancient, flashes of a universe that existed long before Earth formed. Light carries those moments forward, almost perfectly preserved, untouched by the years that have passed for everything else. For light, there is no waiting in the middle of the journey. There is only leaving and arriving, fused into one continuous act. In that sense, light is the universe's memory, because it remembers what nothing else can. Planets erode and change, stars swell, cool, and eventually die. Galaxies collide and reshape themselves into new forms, but the light they cast out into the dark slips away from those changes. Once free, it carries the imprint of a moment that can never be rewritten. Light does not edit the past. It simply reveals it whenever and wherever we are ready to catch it. The oldest light of all this soft cosmic microwave background is especially precious for that reason. It is not just ancient, it is the first memory the universe ever made. It is a frozen snapshot from a time before galaxies, before stars, before anything recognizable had taken shape. When scientists study it, they are reading the earliest surviving page of reality's story, a glowing reminder that even the young universe left a trace of itself in light. And that trace has crossed nearly 14 billion years to reach us now. But this idea of light as memory isn't only true for the most distant or the most ancient. Even the warmth you feel from the sun on your face comes from the past. The sunlight reaching you left the sun about 8 minutes ago. The light you see from the moon began its short trip just over a second before you noticed it. In every quiet moment of your day, you are already surrounded by light that has traveled through time, some of it by minutes, some of it by ages. You live in a constant flood of memories, arriving at the speed of light, each photon whispering, "This is what it was like where I began." Light remembers not only in time and distance, but also in color. The spectrum of a beam of light is like a fingerprint. Within its pattern are clues about the atoms it passed through, the temperature of the star or gas that gave birth to it, the speed at which its source is moving relative to us, and how much the expansion of the universe has stretched its wavelength. Tiny shifts in color, too subtle for our eyes alone, can tell scientists whether a galaxy is racing away or drifting closer, whether the universe was expanding faster or slower when that photon first set out. What is remarkable is that this archive of information is not locked away in some unreachable vault. It is everywhere, washing through the space you occupy, filling the sky above you every night. The universe is not hiding its history. It is broadcasting it constantly in the form of light. All we need are the tools and the patience to read what those photons are saying. In this way, light becomes more than a physical phenomenon. It is the thread that binds the past to the present. Each beam connects us to events so distant in space and time that they are almost unimaginable. Yet their light is right here, arriving on your retinas and on the sensors of our telescopes. The night sky becomes a quiet library, and every faint gleam is a page written long before we ever existed to read it. We are not only readers of this cosmic memory, we are slowly becoming part of it. The light that leaves Earth tonight from our cities, our satellites, our telescopes, even from the sun, as it reflects off our oceans and clouds, will continue on long after we are gone. Somewhere, someday, a distant observer might catch a photon that left our planet in this age. In that instant, they would see a fragile, tiny record of us, a faint signature that says, "We were here." Light is not only the universe's memory, it is also the way we write ourselves into that memory. Every glow, every flicker, every beam that escapes into space is a record etched into the fabric of reality, racing outward into the dark. It does not slow, it does not stop, it does not forget. Light turns existence into something that can be remembered. Every color you see, every shadow on a wall, every shimmer of sunlight on water or faint glint of a distant star is made possible by light. Without it, the world would not simply be dim. It would be formless, without edges or textures or separations. Light is the brush that paints your perception. In many ways, it creates the reality you feel you inhabit. If you picture a room with no light at all, not even the smallest glimmer, you are left with something the mind can barely imagine. There are no shapes, no contours, no indication of where one object ends and another begins. It is not so much darkness as it is absence, an undivided space with no structure for you to sense. The moment you introduce light, everything changes. Boundaries appear. Surfaces gain color. Shadows emerge where light is blocked. The world reassembles itself in your awareness. What we call seeing is really the art of decoding light. Photons bounce off objects or are emitted by them, travel through air or vacuum, and slip into your eyes. There they trigger tiny reactions in your retina, signals that your brain weaves into the experience of sight. You never actually touch the distant object with your mind. You only ever receive its light. When you look at a nearby tree, you are reading photons that have just left its leaves. When you look at a star, you are reading photons that may have been traveling for thousands or millions of years. Your entire visual world is a kind of gentle translation of light's journeys. The deep blue of the ocean is sunlight scattered and absorbed by water. The soft amber of a sunset is sunlight stretched and filtered by the thickening atmosphere near the horizon. Even the blackness between stars is a message. There is little or no light coming from that direction within your visible range. Light does not simply reveal what is there. It determines how it appears. It chooses, in a sense, what is obvious and what remains hidden in shadow. Light also shapes how you feel time and distance. When you look at the moon, you are seeing it as it was a little over a second ago. When you gaze at a bright star in another part of the sky, you are seeing it as it was long before this day, perhaps before any memory you have. Every image is a frame from the past, carried forward into your present by photons. Without light, the passage of time would be harder to sense. Shadows would not lengthen, the sky would not slowly glow and fade, and the quiet cues that tell you the day is changing would disappear. On its way to you, light is not passive. It refracts when it passes from air into water or glass, bending enough to turn a straight straw into what looks like a crooked one. It scatters in warm air rising from a road, making the distance waver like liquid. It reflects from smooth surfaces, producing highlights and glints, and diffuses through clouds and fog, softening edges. Light is constantly being shaped by the world, and in turn, it sculpts your perception of that world. What you see is reality filtered through the behavior of photons and the way your mind interprets them. Color, which feels like one of the most solid parts of our experience, is a perfect example of this collaboration. We speak of the blue of the sky, the red of a rose, the green of a forest, as if these colors are qualities that live in the things themselves. But, in a deeper sense, color is not a property of objects. It is a consequence of how light and perception meet. A ray of sunlight contains a whole spectrum of wavelengths, from deep reds to bright violets and beyond into regions your eyes cannot detect. When that light strikes an object, some wavelengths are absorbed and others are reflected or scattered. A leaf absorbs much of the red and blue and reflects more of the green. But that green is not hovering in the leaf like paint. What actually travels to you is a stream of photons with particular wavelengths. Your eyes receive those wavelengths, and your brain turns them into the sensation you call green. The color is not in the leaf or in the photon alone. It emerges in the act of seeing. This is why different creatures live in different colored worlds. Bees can see ultraviolet patterns on flowers' markings, completely invisible to us, but obvious in their perception. Some birds can sense colors our brains cannot even imagine, shades beyond any word in human language. To them, a simple field or a patch of feathers may look far richer than it does to us. The universe is awash in wavelengths we cannot see, and yet our minds build a complete, convincing world out of the small slice of light we can interpret. From the universe's point of view, There is no red or blue in the photons themselves. There are only energies, wavelengths, oscillations. The beauty we experience, the colors of a sunset, the shades of autumn leaves, the glitter of starlight, is born in the moment when those wavelengths meet a nervous system capable of turning them into feelings. Color is a real experience, but it is not a fixed property out there. It is a quiet illusion woven so tightly into how we live that we forget it is an illusion at all. This doesn't make it any less meaningful. Color helps us tell ripe fruit from unripe, safe from dangerous, familiar from strange. It translates the raw physics of light into a language we can use: warmth, warning, calm, excitement. At the same time, it offers a kind of silent poetry, a way for the universe to express complexity in simple, immediate sensations. A blue star is hotter than a red one, but to us, that difference becomes a feeling. The piercing chill of white-blue light versus the comforting glow of orange. Because color depends on perception, each person's universe is slightly different. Someone who is colorblind experiences a world with fewer shades. Someone else might be more sensitive to subtle differences. Some animals move through a richer spectrum than we do. Each mind paints the incoming light in its own way, just as each culture gives different meanings to the same colors. The photons are the same. The worlds they create are not. So when you look at the sky by day or the stars by night, you are doing something quietly astonishing. You are using light, this tireless traveler, this keeper of memory, to build a world inside your mind. Some of the photons entering your eyes left the sun minutes ago. Some left distant stars long before humans existed. Each one has crossed space without feeling the journey, carrying a hint of where and when it came from. Your brain gathers them, translates them into shapes and colors, and in doing so, ties you to the vast history of the cosmos. Light does not only make things visible, it connects you, in every moment, to a universe that is older and wider than any single life. It lets you read the past directly, not in books or legends, but in the glow that falls softly into your eyes. And as you lie here listening, you can imagine that somewhere, far away, other eyes of other beings, or of no one at all, are also catching their own streams of photons, weaving their own versions of reality from the same gentle river of light. Maybe that is the quiet truth about color. It does not fully exist until someone sees it, and yet it becomes one of the most intimate bridges between the physics of light and the experience of living. It is how light reminds us that reality is not only out there, waiting to be measured. It is also in here, painted softly across the canvas of the mind. Consciousness feels like the one thing that belongs entirely to you. It is the quiet presence behind your thoughts, the part of you that feels, remembers, wonders. And yet, when we look closely at what the brain is doing, a strange question begins to appear at the edges. Could this private, immaterial feeling of awareness be connected in some way to light? It is not as far-fetched as it sounds. Every thought, every memory, every moment of awareness is tied to electrical activity in your brain. Neurons fire, tiny currents flow, and from those currents arise electromagnetic fields. These fields belong to the same family as light itself. The flicker of a neuron, the crackle of lightning, the radiance of a star, they are all different expressions of the same underlying force. Whenever you see anything, light is the first step. Photons enter your eyes and strike the retina. That impact triggers chemical changes, then electrical signals, which travel along delicate neural pathways and spread through vast, branching networks. Somewhere within this intricate symphony of pulses, The raw data becomes an experience. The color of a sunset, the shape of a familiar face, the simple feeling of being here, now. Light does not just reveal the external world. It becomes part of the process that allows you to have a world at all. At that point, the boundary between physics and awareness starts to blur. If photons are the messengers that carry information from the universe into your nervous system, then your consciousness is, in a sense, built on their journeys. Not because light is consciousness, but because your awareness depends on a chain of events that begins with light touching you. The photons striking your eyes tonight may have started their travel in the hearts of stars, crossed empty space for years or centuries, and now end their long flight by helping to shape a thought inside your mind. Some thinkers have wondered if this connection might go even deeper. Light, as we understand it, does not experience time in the usual way. From a photon's perspective, if it could have one, there is no waiting between where it was emitted and where it arrives. All points along its path exist in the same timeless now. Our conscious experience, too, does not feel like a series of sharp, separate instants. You do not sense your awareness as individual frames clicking forward. You simply find yourself in a continuous present, a seamless flow you call now. It is tempting to imagine that the now you experience and the now that belongs to light might share some distant kinship. We don't know if that's truly the case, but the idea is gentle and suggestive, that the present moment you inhabit could be shaped by the same deep rules that allow photons to cross the universe without ever feeling a journey. Some neuroscientists have explored the possibility that the electrical rhythms of the brain, the waves that rise and fall across networks of neurons, might have something in common with the behavior of electromagnetic fields, more generally. Not in the sense that your mind is literally made of visible light, but in the sense that both your thoughts and light itself arise from the same underlying fabric of energy. Your awareness, then, could be seen as a pattern woven into the same kind of field that lets photons race from star to star. If that is even partly true, then consciousness is not something floating above the universe, separate and untouched. It is rooted in the same laws that govern every beam of light and every spark of electricity. The universal speed limit that keeps nothing from outrunning light might also be shaping how quickly signals can move within your brain, how your perceptions are built, how your sense of time unfolds. Your awareness would not stand outside the cosmos, watching. It would be one more phenomenon inside it, another way the universe has found to move, to process, to notice itself. We do not know for certain how deep this connection runs. Perhaps consciousness is only gently influenced by light, shaped by its rules, but ultimately distinct. Or perhaps awareness shares more than we realize, with that timeless quality, an indivisible present, a wholeness that feels less like motion through time and more like a single, ongoing moment. In that view, consciousness could be one of the ways the universe reflects back on its own glow, becoming aware of the light it has been casting into the dark since the beginning. Either way, there is something quietly astonishing in the thought that every moment you are aware, you are moving in step with the same forces that carry light across the cosmos. Every neuron that fires, every photon that enters your eyes, every flicker of perception becomes one more thread in a vast, unbroken web of energy that has been weaving itself since the universe was new. When you open your eyes and look at the world, the story of stars, fields, and light does not just surround you, it becomes you. If you could somehow slow the universe down to a whisper quiet enough that you could sense the smallest exchanges of energy, you might start to feel something like an endless conversation. Not in words, and not in any language we speak, but in the silent dialogue of photons moving, meeting, and changing course. They are everywhere, always in motion, weaving a luminous tapestry that connects every point in space to every other. Each photon has a story. Some are born in the fierce cores of stars, flung outward as nuclear fires turn mass into energy. Others appear when matter meets antimatter, and their existence is converted into pure light. Some photons have been traveling for billions of years, since the universe was young and hot. Others blaze into being and vanish almost immediately in quick exchanges at the quantum scale. Despite these different origins, they all join the same flow, moving, scattering, being absorbed and re-emitted, passing their energy and information from place to place. When a photon leaves a star, it may pass near other stars and feel their gravity tug at its path, bending it slightly. It may encounter a planet, strike its surface, and bounce away, now carrying the tint of whatever it touched. It may be absorbed by a leaf and help drive the chemistry that keeps that leaf alive. It might enter an eye and, for a brief instant, become part of a thought, part of a memory, part of a human life. In this way, photons are not just bits of energy. They are messengers, tying together distant events and tiny moments. This quiet conversation continues everywhere around you. In an ordinary room, light reflects from walls, objects, dust particles, tiny droplets in the air. Photons bounce from surface to surface, some absorbed, some scattered, some finally making their way into your eyes. You do not notice each one. Together, they simply become seeing. But behind that familiar ease lies a vast web of interactions. Each photon's path, a small line in the larger story. On larger scales, light's conversation shapes our understanding of the universe. Galaxies speak through their glow. Their colors and brightness tell us about the stars they contain and how those stars are evolving. When a massive star dies in a burst of light, it sends out a rush of photons that can be seen across great stretches of space, announcing its final transformation. The cosmic microwave background, that ancient glow left from the universe's childhood, is another part of this dialogue. A chorus of old photons that have been traveling almost as long as time itself, still carrying the imprint of that early era. If photons could be aware, they would know no real separation between here and there, or between past and present. A photon has no sense of journey. It does not feel the centuries or the empty distances. It simply is emitted and is absorbed, with no time in between from its own perspective. All the interactions that seem to us to be scattered across eras and light years might, in light's own experience, belong to one continuous act. In that sense, the conversation of photons is more than a poetic image. It is a way the universe genuinely communicates with itself. Every exchange of light between particles, atoms, and larger structures is a small act of connection. We, as observers, become part of that connection. When you raise your eyes to the night sky and let starlight fall into them, you are not only watching, you are completing the journey of those photons. Your awareness becomes the final link in a chain that began long ago in some distant star or galaxy. Perhaps this is what light has been doing since its first appearance, stitching together the scattered pieces of the universe into something quietly whole. Every reflection, every scattering, every glow is a tiny thread binding matter to matter, moment to moment, and mind to cosmos. It is an infinite conversation, carried on without pause, not in sentences but in paths. If light could speak in a way we could understand, its voice would not need to be loud. It has had almost the entire age of the universe to tell its story. Maybe it would not sound like words at all. Perhaps it would feel more like a presence, a gentle sense of movement and arrival, a story told in journeys rather than phrases. It might begin by describing the place it came from, the crushing heat in a star's heart, the swirling dance of particles where it was born. It might hint at the galaxies it passed and the long stretches of quiet space in which nothing touched it for ages. And then, in the softest possible way, it might say, "For me, there was never a long road. I was there, and now I am here. And in between there was only a single unbroken now." You, listening to that imagined voice, are part of the same story. The photons that reach you, the neural signals they spark, the awareness that arises from them, all of it belongs to one universe, one great exchange of energy and information. Light does not stand apart from that exchange. It is the way the universe remembers, speaks, and in some small, luminous way begins to know itself. Light is a patient witness. It does not age as it moves. It does not wait or hesitate. It does not forget where it has been. If it could somehow tell its story, the oldest photons, the ones that make up the cosmic microwave background, would speak in a very soft, ancient voice. They would remember a time when the universe was a dense, searing fog, when space itself was small and hot and filled with energy. They would remember the moment everything cooled, just enough for the first atoms to form, when the fog thinned and they were finally free to travel outward. Since that moment, they have been moving, carrying that memory across an expanding cosmos, a quiet message from the universe to itself. Light would also remember us. It has bounced from the surfaces of oceans and snow, slipped along the glass of our windows, skimmed across the leaves of trees, and reflected from our faces. It has passed through the eyes of every living thing that has ever looked up at the sky. It has been caught in paintings and photographs, focused by lenses, recorded by telescopes. Every candle flame you have watched, every lightning flash, every slow unfolding of a sunset, all of it has been light speaking in its wordless way. If light could choose a single sentence, it might be something like, "I am the bridge between everything." It links distant galaxies to your gaze. It carries the memory of stars that died before Earth existed. It binds cause to effect, because nothing can influence anything else faster than light can move. In that sense, it is both messenger and boundary, the thread that ties space and time into one continuous fabric. Perhaps light would also wonder if we realize how much of it we carry inside us. Every atom in your body was forged in stars whose cores once burned so intensely that they filled their surroundings with light. You are made of matter, but you are also made of what light has left behind. You see, because of light, you know the wider cosmos, because light has reached you. Without it, there would be no perception, no memory of distant events, no way to witness anything at all. If light could speak, it probably wouldn't sound like a lecture or a revelation. It might sound more like a gentle reminder. I have been here since the beginning. I am here now. I will still be moving long after you are gone. Everything you know, everything you see, every story you carry depends on me. And in a way, it has been saying this for as long as there have been eyes to see and minds to listen, not in words, but in the way it travels, in the way it fills the space between stars, in the way it arrives after crossing distances that seem impossible. It speaks in every sunrise, every shadow, every scattered sparkle on water. We have always been hearing it. even when we did not yet have the language to say so. Time, for us, rules everything. It moves forward, whether we want it to or not, ticking itself into seconds, minutes, and years. We grow older under its steady pace. Planets circle their stars in its rhythm. Stars are born, live, and die according to its slow counting. For us, time is inescapable. For light, it is different. From our perspective, a photon races across space at about 300,000 kilometers every second, traveling for billions of years from the most distant galaxies to reach our telescopes. We see those journeys as long histories, but from the point of view of the light itself, if such a point of view could exist, that entire journey takes no time at all. The instant a photon is emitted, it is, in its own frame, already at its destination. There is no during, no long in between. All the points along its path are gathered into a single, unbroken now. Relativity tells us why. The faster you move, the more time slows down relative to someone who is not moving with you. If you could somehow accelerate all the way to the speed of light, time in your own frame would not merely slow, it would stop. A photon does not age. It does not feel the seconds. It does not know before or after. It moves in a way that makes time irrelevant. That means the glow of a star that left its surface 10 billion years ago, and the moment that same light enters your eye are, for the photon, the same event. No wait, no gap, no passing of ages. We experience the universe as a sequence, one moment following another. Light, in a sense, belongs to a different kind of reality, one in which those moments are stacked together into a single whole. This is why light feels so fundamental. It is not only fast, it sits at a kind of still center. It is motion that erases the very idea of duration. Matter slows, decays, transforms under the weight of time. Light moves as though time has no hold on it. It is the closest thing we have to a bridge between what changes and what endures. If you could somehow see the cosmos the way light sees it, you would not see a flowing river of moments. You would see a vast, interconnected pattern where every place and every event coexists in an eternal now. We can only glimpse that view from the outside by watching what light does. But even that glimpse is enough to suggest that time may not be as rigid or absolute as it feels inside our lives. Light does not just let us see the universe, it helps us understand it. It threads through time without being bound to it, showing us that the difference between then and now depends on who is looking and how they are moving. When we look into the night sky, we aren't simply peering backward. We are touching, very lightly, a state in which past, present, and future are wound together, all stitched by the constant speed of light. And somewhere inside that, there is us. If you pause for a moment and think about it, you have been wrapped in light for your entire life. Every morning, every reflection in a window, every flicker of a screen, every scattered sparkle on a rainy street, it has always been there, quietly shaping the world you inhabit. But the truth goes deeper than simply being surrounded by it. You are, quite literally, made from things light created. Long ago, the first stars gathered under gravity and ignited. Their cores were so dense and hot that they fused simple elements into heavier ones. Hydrogen became helium. Helium became carbon, oxygen, iron, and more. The ingredients that would one day become rock and water, air and bone. Those furnaces were flooded with light. When the stars died, they spilled their elements into space. Those remnants mixed into clouds of gas and dust. From those clouds, new stars formed, planets took shape, and eventually, on one small world, living cells began to arrange those elements into bodies. Every cell in you contains atoms that once sat in those stellar hearts, lit from within by their glow. The light you see in the sky is not something entirely separate or distant. It is part of your own story. The physics that pours photons into space is the same physics that forged the matter of your muscles and your blood. Even now, light runs quietly through your life. The energy you use each day began as sunlight, captured by plants, transformed into food, turned into warmth, motion, and thought. Your eyes are tuned to light. They evolved specifically to catch and decode its signals. Every moment you are awake, photons are entering you and becoming part of your experience. Without them, your awareness of the outer world would go dark. To be made of light in this way is to be intimately connected to the universe that shines above you. The starlight that crosses vast distances to reach your eyes is not just something you observe. It is kin to you. It is the same kind of energy that shaped galaxies, kindled stars, and eventually gave rise to beings who could look back at that glow with curiosity and tenderness. Planets, stars, even galaxies will someday change beyond recognition. They will fade, collide, or be remade. Light keeps going. It moves on, carrying traces of what once was. And so do you, in a softer way. The atoms that form you will someday drift elsewhere. The light that has passed through you will continue, its journey unbroken. Some part of what you are now will remain folded into the universe's ongoing radiance. So when you rest under the night sky, you are not just looking at distant suns. You are sitting inside the same story that created you. The soft glow overhead and the quiet life inside your body are different verses of one long song, written photon by photon across space and time. Light does not hurry, it does not struggle, it simply moves, unbothered by time, untouched by distance, connecting everything to everything else. In its steady, silent motion, there is a kind of peace. The universe has been unfolding in this way for almost the whole span of cosmic history, slowly, patiently, without rushing, and you, just as you are now, are part of that unfolding. If you let that thought settle, it can feel like a gentle hand on your shoulder. The photons from distant stars are falling softly through the darkness, as they have for ages, as they will for ages more. You are not separate from that glow. You live in it. You came from it. And even when your own brief moment has passed, the light that shaped you will still be on its way, carrying a faint trace of your existence into the vast, quiet night.